In this video, we're going to talk about hydrometeorological hazard maps. So the learning competency for this one is to interpret different hydrometeorological hazard maps, and the specific learning outcomes or objectives are the following. So first, let's define what a hazard map is. A hazard map is a map that highlights areas that are affected by or are vulnerable to a particular hazards. They provide important information to help people understand the risks of natural hazards and to help mitigate disasters. So, hazard maps basically indicate the extent of expected risk areas and be combined with disaster management information such as evacuation sites, evacuation routes, and so forth. Okay? So one feature of a hazard map is it includes a time frame or a likelihood reference. Okay? For example, this one. This map shows the 2010 National Seismic Hazard Model for New Zealand. So this shows expected peak ground accelerations for a 475-year return period earthquake for shallow soils. Now I have mentioned the word return period. So what is a return period?
What's up with that?
Return period is also referred to as the recurrence level. So it is the probability of an event such as a heavy rain, intense typhoon or floods to happen. So it is a statistical measurement mainly based on historical data, which gives the estimated time interval between similar extreme events. So there have been a lot of studies about tropical cyclones, particularly here in the Philippines. For example, this one, return period and Pareto analysis of 45 years of tropical cyclone data from 1970 to 2014 in the Philippines. Here they have found out that six tropical cyclones caused 80% of the damage costs and deaths in the Philippines. For example, the return period of a heavy rainfall event is 100 years. This can be expressed as an event with a probability of happening equivalent to 1 over 100 or 1%. This does not mean that the next similar extreme event will happen 100 years after. Instead, it means that in a given year, there is 1% chance that the event will happen. Consequently, 100-year floods can happen in two consecutive years. So, in analysis of extreme hydrometeorological events, return periods are usually used to infer the severity of an event. Okay? So, this table shows the modified Corona's climate classification. So, remember, Philippine climate zones traditionally were classified from a rain gauge network using the MCC, or the Modified Coronas Classification. MCC uses average monthly rainfall totals to define our four climate zones. We have here type 1, type 2, type 3, and type 4. Okay? So to summarize, type 1 and type 3 have wet and dry seasons, whereas type 2 and type 4 have wet seasons but no dry seasons. Rainfall is the most important climatic element in the Philippines. So the distribution throughout the country varies from one region to another, depending upon the direction of the moisture-bearing winds and the location of the mountain systems. So the mean annual rainfall of the Philippines varies from 965 to 4,064 millimeters annually. So Baguio City, Eastern Samar, and Eastern Surigao receive the greatest amount of rainfall, while the southern portion of Cotabato receives the least amount of rain. So at General Santos City in Cotabato, the average annual rainfall is only 978 millimeters. So aside from rain gauge monitoring in different parts of the Philippines, Pag-asa publishes regularly updated color-coded satellite images as you can see from this figure. This is from the Multifunctional Transport Satellite or MTSAT to visualize rain distribution across the country. So the color code is as follows. So the color red here that you can see represents heavy rain. The yellow ones, light to moderate rain. The white portions are clouds. And the blue, it means clear sky. Okay? Actually, this is the old one. Last 2015, Pag-asa changed it to what we call the Himwari 8. So the Himwari 8 is a geostationary weather satellite, successor to Japan's MTSAT series. Okay? It was installed at Pag-asa last December 2015. It is the most utilized satellite imagery in real-time weather forecasting, tropical cyclone analysis, and for research purposes, as it generates images every 10 minutes. Soon, we will have the Himwari 9 from 2022 to 2029. If you want to learn more about this, you can visit Pag-asa's website at bagong.pagasa.dost.gov.ph. So the Pag-asa website looks like this. Here you will see the date and time you accessed it. You have different tabs: weather, flood, tropical cyclone, climate, etc. You will also see here some active warnings and the real-time satellite image of the Philippine Area of Responsibility. In the left part, you will see a forecast for certain places. Now, if you notice, you have here the weather station. So this one is taken from Tagaytay AWS. So in addition to the satellite observation, Pag-asa operates 14 weather radar stations as of 2016 all over the Philippines. So this figure shows the location of these weather radar systems. So weather radar, as we have discussed, can detect hydrometeors, meaning rain or clouds, by transmitting electromagnetic radiation to the atmosphere, then analyze the returning echoes reflected by weather elements present in the sky. This figure shows a sample radar image over Bataan, also using a color coding scheme to visualize the rainfall region. Now, another product of Pag-asa is its watershed monitoring network for flood monitoring system. So using water level sensors that measures the height of the water level of major river systems, users can monitor impending flooding in major river systems in the Philippines. So this figure shows flood information from all over the country. So if you visit the Pag-asa website, you will see this one. As you can see, there are 18 major river basins as of the moment and 4 sub-basins, or what we call the dams. Okay, so if you click some of the highlighted regions, you will get a notice like this one. I clicked one area, then this shows. So this shows the rainfall forecast on that region that you clicked and some instructions. Okay, for example, here, the instruction is to take necessary precautionary measures. Okay, now this one shows the flooding monitoring in Metro Manila. Okay, you can see here the water level, rainfall, warning post, and the AWS. So next time, if we have a tropical cyclone, try to look at this one, and you will see how chaotic it is.
Oh, what?
Now, months prior to the onset of El Nino, Pag-asa publishes dry or drought spell outlook like this. Okay, this can warn us of impending dry conditions so we can prepare for such extreme events. So these are also regularly published to report unusual climate conditions in different parts of the Philippines. We also have what we call the Project NOAA. NOAA stands for Nationwide Operational Assessment of Hazards. So Project NOAA is the response to the call of the previous president for a more accurate, integrated, and responsive disaster prevention and mitigation system, especially in high-risk areas throughout the Philippines. So this project harnessed technologies and management services for disaster risk reduction activities offered by DOST through Pag-asa, PVOX, and the DOST ASTI, or Advanced Science and Technology Institute. This is in partnership with the National Institute of Geological Sciences, and the UP College of Engineering. So right now, due to the lack of funds, Project NOAA operates under the University of the Philippines. So the NOAA website displays the Pag-asa radar data, rainfall measurement of rain gauges of the OST, and has flood hazard maps for different regions of the Philippines, with 5-year, 25-year, and 50-year, and even 100-year return periods. So as you can see here, it's the 5, 25, and 100-year flood maps of Marikina, and this one is for Cagayan de Oro. Another local website is the www.nababaha.com. It is a non-profit project by the members of the Volcano Tectonics Laboratory of the National Institute of Geological Sciences of the University of the Philippines. So this publishes a list of hazard maps of different regions. Okay, this has the same dataset as the OST Project NOAA. We also have the National Mapping and Resource Information Authority. This is an agency of the Philippine government under the Department of Environment and Natural Resources, or DENR. It is responsible for providing the public with map-making services and acting as the central mapping agency, depository, and distribution facility of natural resources data in the form of maps, charts, text, and statistics. You can go to this website by visiting www.nomria.gov.ph. Okay, we also have the Mines and Geosciences Bureau, or the MGB. This is a government agency under the Department of Environment and Natural Resources, who is responsible for the conversion, management, development, and proper use of the country's mineral resources, including those in reservations and lands of public domains.
제 영상 많이 찾아봐 주세요. 아, 이거 해야 돼. 좋아요랑